Hey everyone, and welcome to the Tom's Hardware Piecast for December 8th, 2020. We are just having some folks start piling in our viewership, and today's special guest is John Jones, who's going to talk about a really cool rocket project. And we also have, as always, Associate Editor Les Pounder and Raspberry Pi expert Ash Puckett. And as always, I'm Tom's Hardware Editor-in-Chief Avram Pilch. And we're going to talk some Pi. So John, tell us a bit about yourself. How did you get into Pi and rockets? And what do you do when you're not shooting off Raspberry Pi rockets?
So I'm a software engineer by trade. So I've been using Raspberry Pis for a long time, just in work projects, home life projects. They, as you guys know, they kind of fit the bill for a lot of different reasons. And was really into rocketry as a kid. And then over the summer, started thinking back to that and kind of chatting with friends and thinking about, well, geez, couldn't we do something fun as a little side project with a Raspberry Pi and a model rocket? So back in July, August, started looking into designing my own onboard telemetry module for a model rocket, and began kind of speccing out what that would be. So then back in September, finally had kind of a prototype built, and took it out for a spin in Leesburg, Virginia. It had a very successful launch, and all kind of based on a Raspberry Pi, which was really exciting.
Great. So can you show us what your rocket looks like?
Yeah, absolutely. So I have it right here. So here's the rocket. It's probably about 3-ish feet tall. And it's all based on, there's a model rocket company called Estes. There's a bunch, but that's sort of a well-known one. It's all based on kind of stock parts from them. And then based on the design uses an engine called a D12. That's a really well-known model rocket hobby engine. But then the really fun part from a Raspberry Pi standpoint is this guy. This is the onboard tracking module. So the whole thing is the mount is a custom 3D printed design, sort of just a series of struts. And then you can see up close here, there is the Raspberry Pi Zero with some very bad soldering. At the base here, this is an Adafruit power boost. So it takes voltage from a little battery, boosts it up to 5 volts, and powers the Pi, which has an onboard camera, shoots at 90 frames per second. And then up here, kind of through this spaghetti mess of wires, are a number of different modules. So it's got a accelerometer, so I can tell the attitude of the rocket as it flies. It's got a pressure sensor and temperature sensor. So we use the pressure sensor to determine altitude. As it goes up, the pressure decreases, and we can estimate pretty accurately what the altitude is, which is very cool. Then it has a 915 megahertz Packet radio transmitter. So all the software on board is all Python code I wrote. So it takes readings multiple times per second, packs those into an array of floating point numbers and transmits those on this radio to a ground station, which I'll show in a second. And then at the top, something I've actually added since the first launch, been working on that right now, is a GPS module. So my goal for the spring is to start doing some more high-powered launches where I want to track the rocket out of line of sight. And so having GPS data from it obviously will be very useful for that. So all of this fits up inside the top part of the rocket. So if I pull that apart, there's a window for the camera there. This just slides up right inside of it. And then there's this coupler, which I use rubber bands to kind of attach that whole section together, and that's the assembled rocket. Once it reaches its peak altitude, this separates and a parachute will come out. So the whole thing can parachute safely back to the ground. And then on the ground, I have this very improvised ground tracking station. The other thing I want to work on is actually building a case for it. But it's got a full-size Raspberry Pi, another GPS module, and a corresponding packet radio chip set to receive mode. So it pulls down those packet radio transmissions, and I have kind of a dashboard that Ash, I think you showed on a previous episode. On my laptop, I can track it in real time as it flies. And the onboard unit also logs everything to a CSV file on board. So I have lots of data saved in all kinds of different places. But yeah, so the first launch was a big success, which was really exciting. It flew about 300 feet. So in the spring, of course, now that I've proven it works, I want to try to go higher. So I think I can probably get it up to about 1,500 feet with some higher powered motors.
So how far, what's the range of that packet radio?
So the documentation says it could go up to like 2 kilometers. I've not tested that, so I probably should go do that. Go out into a field and just walk around with the rocket and see what kind of signals I get. But the advertised limit is about that range. And for this application, I'm pretty confident in that, because if you're launching a model rocket, you're going to be out in a field. You're going to be away from populated areas. So you're not going to have a whole lot of obstructions other than maybe some trees or the occasional house. So it should be able to track pretty accurately. But that's something in the spring I'll need to do some more proving around.
Wow, neat. Ash, you covered this as one of our top Pi projects. What are some of the things that interested you the most about it? I think you're muted. I think you're still muted. So while she's doing that, let me ask you a different question.
Sure.
What type of battery are you using, and what type of and is it giving you enough power to do this multiple times?
Yeah, it is. So this is also from Adafruit. It's a 3.7 volt LiPo battery, and it puts out plenty of power. So when I was testing this, I ran it for hours, just seeing how long I could get out of it. So I think like it ran for 3 hours successfully with all the sensors working. I've not tried it since I added the GPS module, so need to do some testing around that. But these flights last, a few minutes, so it provides plenty of power for the application. If I was going to do a day of testing, I might maybe order 1 or 2 extra ones. So it's always good to have spares. But yeah, those little batteries provide an immense amount of power.
Wow.
Can you
great.
John?
That's great. That's great.
Oh, Ash,
your
we can hear you.
dashboard that you were talking about, you mentioned I showed it on a previous episode. It looks wonderful. And when you're wanting to track that information in real time, it's just so good to see everything at a glance. You've got your meters and your gauges. I have a question about it.
Yeah.
So a lot of it you put together yourself, right?
Yes. Yeah.
Okay. Was that out of necessity, or did you find similar projects online that kind of helped inspire your final product and design?
So my final product and design, I think, so I've been a big space buff for a long time. So I was always like, as a kid, like sort of obsessed with like the movie Apollo 13 and Mission Control and all that. So I sort of a little bit modeled it somewhat with a little bit of sentimentality to it, kind of harkening back to like kind of those displays. But yeah, I've actually, as part of kind of my phase 2 of this, I went back and refactored a lot of my code and have been rebuilding that dashboard to be a little more refined. So that's coming out shortly. But one of the big things I'm adding is, like I said, that GPS tracking. So that's going to be a new view on there to show like bearing and distance to where the rocket is. But yeah, the live view was really, really useful when it was flying, just to see like in real time how fast was it going. Were the sensors recording even at all? Because I wasn't even sure if it would work going off the launch pad like that.
Yeah, that's probably the coolest part, because you're not just checking a log afterwards to see what it did. It's
correct.
like, I can see it, and there's a number getting bigger.
Correct. Yeah, it was pretty cool. It was pretty cool. Pretty cool.
That's awesome.
Yeah.
Les, you
John, I noticed when you were showing off the insides of the rocket, there's quite a lot of Adafruit parts in there.
Yes.
Was that a conscious choice to get Adafruit parts, or did you just go off to find different parts in different places? How easy was it to source the right parts?
Yeah, I mean, so I often go with like Adafruit parts because their libraries are so easy. So for all those different sensors, they usually publish a Python package for it. And so like I knew like whatever sensor I bought and kind of doing some research, there would always be a compatible Python module. So it would be very, very easy to interpret the data from those different models. I wouldn't have to write my own parsing of the data coming in. So that made it really easy to put together very quickly, like a simple telemetry tracking program. Again, which I'm refining to be a little more robust. I have it posted on my GitHub.
So Mike says these are the same batteries that are in vaping and laptops. This is true. And not to distract from this segment, but if Mike or anybody else has some great battery advice for me, I'm always looking for it. I'm still looking for great battery advice, as my son and I are doing a bunch of robots. RC robots, and we're trying to find a way that he won't set on fire, but will also comfortably mount because if you take like a USB, I mean, obviously the easiest thing for the Raspberry Pi is to get a USB power bank, but that's not great for if you're trying to put it on a robot car or something. You're not going to mount a power bank on here. So what I see a lot of people do is use batteries like this. But for Raspberry Pi, you have to do something to adapt them. And then I have to make sure he doesn't put them in backwards.
Right.
Because apparently I've read that if you put them in backwards, they will catch fire, which might be how this car ended up catching fire a few weeks ago. Because it did. The VRM was, so I'm always looking for good battery tips. Good battery tips. It seems like that one single battery was definitely good enough to power the Pi, although we don't know if it would be enough to power motors or something like that. Yeah,
right, because it's really not doing a whole lot of work in this scenario. It's not powering anything mechanical. It's just running a few IC chips.
Cool. So how does the rocket itself get launched?
Yeah, so the motors they're just basic black powder. They've been produced for, like, I got into this as a kid because my dad did it as a kid. That they've been around for a while. But at the tail end of the rocket here, you can see there's just a cylindrical opening, and the motors they're cardboard with, it's almost like sort of a clay inside of them that holds the powder in place. So you put one of those in there. They're maybe like 2 or 3 inches long, and then there is an electric launch controller. It's got 2 little alligator clips that you clip to a little igniter. It's got a long cord. You get back. There's a safety key you put in. It tells you have a closed circuit. You ignite it. It takes I think 4 AA batteries, not a whole lot of power. And it ignites this little igniter at the end of the alligator clips. And that's just enough to light the black powder. And the engine will fire for only 2 or 3 seconds. And in that time, it gets really high really quickly because these aren't that heavy. So they don't need a whole lot of energy to get higher. So those are kind of the basic motors, but the ones I want to start working with in the spring, they're based on more of a composite material that are much more like real solid rocket boosters that you would see on like the side of like the old space shuttle and things like that. So those need more high-powered launchers and a little bit more safety precautions to do. So I'm going to be looking into doing that a little later in the spring.
Where does one go to fire off a rocket like this without hitting a tree or getting in trouble?
So I live just outside of Washington, D.C., near Ronald Reagan National Airport. So I can't do it near my house at all, or that would be very problematic. And just in the D.C. area in general, like so many cities, anything going up into the air is pretty highly regulated. So here in the D.C. area, out in Leesburg, Virginia, there's a park where you can file for a permit for flights up to 400 feet. So this was perfect for that. So filed the permit, got it approved pretty quickly. And this only went 300 feet, so that was very safe. It's a big field where everyone could see what I was doing. So you can do that there. But then regionally, there's also model rocket clubs. So there is a Virginia one, which I'm going to be looking into in the spring. So I could do some of those more high-powered, a little more safety protocol specific launches. But that's really the best way to get involved with it if you've never done it before, the regional rocket clubs. So I know Virginia here has one, I think, in most major areas. There's a club that meets once a month to organize launches in a very safe way.
Cool. Well, that's awesome. So the best place to find out more about what you're doing is to go to your site, johnjones4.com.
Yeah, my site. I've got 2 blogs posted about this already, about the design process and the launch day, detailing the first launch went really well. The second one didn't go so well, so you can read about that. And then after I do all these upgrades, I'll be posting there again. And there's also a link to the GitHub project where I have all the code posted. And a couple actually different rocket teams at some colleges have been reaching out to me about forking that code, which is pretty exciting. So definitely check that out there as well.
Cool. So this week there's going to be, in the PC world, there's going to be a really big launch of its own kind, which is Cyberpunk. And we teased in our show description that we would talk a bit about Cyberpunk on the Pi. The news isn't all good, but we will give you the news. Les, you've been working on a Cyberpunk 2077 Pi mod, and you've also been testing whether or not it might actually be possible using cloud gaming to play Cyberpunk. What have you found out?
Okay, so for the last 2 days, I've been messing around with a Raspberry Pi 4 inside a custom aluminium case. Here's a sneak preview of what it hopefully will look like. Let's just try and get that so it's lit up nicely. I've got an e-ink display. This is a Pimoroni Inky Fat, and this aluminium case with some hazard tape to make it look all cyberpunky. And it's been battered a bit, mainly by me trying to file it. This was running standard Raspberry Pi OS and Geforce Now. Now, if you're not aware of Geforce Now, it's a way of playing your PC games in the cloud using a cloud server. Geforce Now does work on the Pi. And I was playing Deus Ex on here, the Mankind's, the second or third game it was. And it played, and it looks stunning. But unfortunately, you can measure the frames per second as in frames per minute. It was really slow. So to move the character from left to right in a sweep with the rifle would take about 45 seconds. It looked stunning when it did it, but it was just really too slow. So I tried that. I tried Stadia, and I tried a few hacks to overclock the Pi and to overclock the GPU, etc., in getting this up to 84 degrees C, which caused the Pi to throttle. It was very interesting. Actually, it was really hot to hold. Unfortunately, it didn't work, but it gave me a lot of interesting information to base on future projects. So I was looking into Vulkan on the Pi, because you can render Vulkan in a web browser. It's part of Chromium's backend. That didn't work, unfortunately. Overclocking GPU didn't work, but it's all useful information for future projects and future investigations.
Well, there's, we will still be trying to get, we will hopefully be further on the case mod in future. And, but, it would be shocking if we were able to play really smoothly using cloud gaming on a Raspberry Pi. But we'll see. So you have another toy that you wanted to show us that's pretty cool that you got.
I have, yes. The Nebra Anybeam hat. Now that sentence doesn't mean anything. It's just name the company, name the hat. What is it? Well, it's a laser projector hat for a Pi. So let it sink in for a moment. It's a hat that goes on a Pi that projects using a laser. And I've got it running in front of me right now, and I've got a very crude screen, which is a piece of A4 paper. And hopefully you'll be able to see. Let's try and get this in shot. You can see the PiCast, the episode with Lady Ada and Philip from Adafruit. So this is only about, let's say, about 60 centimeters away. I can project up to 3 meters away a 720p video at 60 frames per second onto a 150-inch screen. I don't need to focus. There's no bulbs or anything. Just plug it into the Pi. It goes on top of the Pi on the GPIO. You can just see me now. It'll put on top of the GPIO of the Pi. You run an install script I got it from the Pi Supply website. Pi Supply is the UK supplier of this board. And it just ran the installation script, and it worked straight away. So, brilliant piece of kit. I'm going to do a review of this on Tom's Hardware. But I'm going to tell you, first of all, how much this thing is. I'm just going to cover it up so I can actually see. And don't shine lasers in your eyes, it's dangerous. This is 200 UK pounds. So that's roughly $250, maybe approaching to $300, which is a lot of money for this hat. It's a lovely piece of kit, but it's a lot of money. And it also runs excessively hot. So I've got it in front of me right now, and I've got my laser thermometer. I'm just going to fire at the heatsink to tell you how hot it is. It's at 58.2 on the heatsink, and on the aluminium, 49. But I've got a Pi 4 under there, which is running really warm as well. So once you set it up, be careful with it. You might burn your fingers. But as I say, its picture quality is superb, considering it's a 720p screen.
And that's handled entirely through GPIO? There's nothing connecting it to HDMI?
No HDMI connection whatsoever. You can just see me over the paper. It's all through GPIO.
That's neat.
Yeah.
The picture quality is fantastic. Really nice. You're getting a flicker here. I can't see that in real life.
Yeah, so it sounds like it's just a translation to our show that's Oren asks, where is the bottleneck for cloud gaming on the Pi? I guess, is it the bandwidth? Is it the processing?
I think for the Pi right now with Geforce Now, it's GPU based. There's no hardware acceleration in the browser of sorts. I mean, there's been vast improvements with the latest Raspberry Pi OS release last Friday, which saw YouTube performance really impressive now. But for GeForce Now, there's just not the performance in the GPU to give us a nice smooth frame rate. That coupled with input lag perhaps, because when you move the character, you will have a noticeable delay. That could be down to just the time it takes for the Pi to process the video image with the GPU, rather than actual input lag. That needs to be proven. But right now, we can't prove that on a Pi, unfortunately. We need to wait and see if GeForce Now will become an official release, or some enterprising hacker out there works out a way to make it work.
Maybe Vulkan 3D will help with this.
I sincerely hope so. I downloaded PiKiss, which we covered on Tom's Hardware quite a while ago, which is an installer program to install all the commonly used applications for a Pi, make it really simple, hence the KISS acronym. And that installed all the latest Vulkan drivers, the very latest one, so I was quite impressed with that. And unfortunately, it still didn't work. But hopefully, with the way Vulkan's improving day by day with the team working on it, we're going to see some fantastic results.
So, John, have you tried doing any cloud gaming on a Pi?
Have I? No, I've not.
I mean, it seems like the issue here is that you just need better hardware acceleration. It's who knows? I mean, GeForce Now I don't think is officially supported, so it's through the browser. If there was a GeForce Now native, it might look better. Who knows?
Yeah, I had to hack it. There's a way of spoofing Chromium to make it believe you're running a Chromebook. So that's what I did.
Bald Pope asks, what is the rated lumens of the projector?
Well, my friend, it's very handy. I've got the spec sheet just here. Really handy. It says it's 23 ANSI lumens, which is equivalent to 130 visual lumens for a DLP projector.
Not bad. Not bad. So, you know, if you're looking to project things with your Raspberry Pi, it sounds like it's a decent choice. Although I haven't priced it recently, but it seems like you might be able to just get a regular projector for less. I'm not sure. I think you're paying a premium to get it as a hat.
Stick it on a Pi 400.
Right. I mean, it seems like you could probably get just one that operates over HDMI for less, but still, it's pretty cool. Maybe someone will give one as a gift. So I know, Ash, you wanted to talk today about gifting, since we're only a few days away from Hanukkah and a couple weeks away from Christmas. People might be giving Raspberry Pi stuff as gifts.
It's true, and you're going to see my face here in just a second if I can get my camera to work. But I have a few things that I want to talk to you guys about, because there's still, like Avram just said, there's still plenty of time to make some really cool presents for your friends and family way before the holiday hits, using our favorite SBC, the Raspberry Pi. So I've got a few gift ideas and holiday-themed projects that you can use for inspiration. And I tried to include a little something for everyone. So if you want something cool or something budget-friendly, there should be plenty here to get the jogging noggin. So first up, a little bit of decor. It's a motion-activated Christmas lights project, because you don't really need much more than probably just a Raspberry Pi Zero to make this work. Set it up with an ultrasonic sensor or an IR sensor, and you could use a Python script to trigger LEDs, or even a relay. If you want it to respond to sensor change, you could control something like an entire Christmas tree if you're using relays. This project also would be possible with something smaller like an Arduino, but if you want to incorporate a Raspberry Pi, you could use that to control several of them on a larger scale and trigger more complex responses and have like the craziest, I don't know, I'm picturing a house on the side of the road and people drive by, the lights just trigger. You could really go far with Raspberry Pi projects, and I think motion activated Christmas lights is a good place to start. Next up, we've got a train passing by, if you could ignore the train behind me. But I have another idea that I think is just wonderful for friends or family, especially this time of year, because it's really hard for us to get together. And this idea is for a digital picture frame. I can't get there we go. A digital picture frame. And I think it would be really neat if you were to use an e-ink display, like in this project I have pulled up on Tom's Hardware. I featured it a couple of weeks back. This one maker used this project idea to play his wedding video back one frame at a time. But I just think it's a really cool project idea because you could make it for your family, update the pictures over SSH, maybe even from your house. Just send some pictures to grandma's house, call her on the phone, say, hey, are you looking at the mantelpiece? Okay, I'm going to send some pictures from our vacation. It's just a really fun idea if you get creative with it. So I thought that one would be worth bringing up.
Pimoroni has a really nice, although they were out of stock last I checked, color e-ink.
Yeah, that's even cooler. That's an even better idea. If you can find the color ones, they just look so good. And if there's any kind of power disconnect to the e-ink display, I'm pretty sure that whatever was on there last stays on the screen. So it's just a really good screen to use for any kind of digital picture frame. Next up, this next project is a little more technical, but I think it's a classic, and it always hits well with anyone who's outside of the Raspberry Pi community, and that would be a smart mirror. Because there's just so many different ways that you can integrate it into however you want to use your technology. If you want it to show weather information or simple stuff, local things, traffic, maybe train station schedules, things of that nature. You can just configure it to do whatever you want. Maybe you want it to show emails or something. But this kind of project would be fun to set up for maybe someone close to in your family. Just it's totally original, totally fun use of Raspberry Pi. But like I said, it is a little more technically inclined than some of the other ones.
I've been dying to do one of these. I want to build one so badly.
Yeah, John, you mentioned that around your house you've been doing some IoT stuff. Anything like any of these?
Yeah, actually, thinking the e-paper one. I do. I have a couple different e-paper panels that I've gotten from Waveshare, but their prices are pretty good. But yeah, I made I printed a 3D case for one with a Raspberry Pi Zero backing it. That's stuck to our refrigerator, and I have it hooked up to Todoist right now. So my wife and I have like a shared household to-do list we manage with Todoist, and it shows it on the fridge. And yeah, it's great because it's in our kitchen, so we have to unplug it to use the mixer or something. Everything stays up there until you plug it back in. So the image staying after power is gone is actually a very, very practical thing for household kind of connected device things, because sometimes you just got to unplug things and you lose power, and you don't lose quality as a result.
Yeah, Adafruit was showing us a few weeks ago that they have a new product called the Magpie. Not Magpie, MagTag. It's not Raspberry Pi, but it's an independent module that you can program over Wi-Fi that is battery operated, and you can use it as a magnet and stick it anywhere, cool. And it just works. You could give it a feed. It's I think it's $40 on their site. So pretty cool thing. Not Raspberry Pi powered, but yeah. But just really, really simple. It's just made to just do that. So what else was on your list?
I got a couple more things for us here. Now, if you've got someone in your life who's really into retro gaming, you've got to make them a retro Pi rig. Do you even love your friends if you're not building them a Picade? This picture's from Les's posts. That's his Picade. It looks really good. But it's yeah. If you're not familiar with RetroPie, which I'm sure most people watching probably are, but just in case, RetroPie is basically a platform for emulating not just old consoles, but you can emulate computers, older computer systems, operating systems, things like that. All you need essentially to build one is a Raspberry Pi, power supply, a screen, and a controller, and probably a computer to set up the Pi. But if you have all of that, you can have someone you love in your life gaming in no time. And that also leads me to my last thing that I wanted to share. I think it's really cool. This is the GPi case. So this is similar to the last project. Let's say you want to build somebody a retro Pi rig, but you want it to look more professional and put together. This case, or I like to call it kind of a kit, it's designed to look like an original Game Boy. And inside where the cartridge would be is a Raspberry Pi Zero. And the whole system runs RetroPie. I think it's easier to buy a kit with everything you need rather than searching for each individual component. And it was just too cool not to bring up the GPi case. I know that Avram's got one. I've got one. We both love it. The screen looks good. The performance is good considering it's got a 0W inside. It handles, like it's not going to play an N64 game, but you can play some Super Nintendo stuff, and there's no quality drop there. It's pretty good. And with that, I wanted to pass things over to you guys with a question. I wanted to know if you guys have seen any cool holiday-themed Raspberry Pi projects, or if you had any cool ideas for some that you haven't seen yet.
Well, I have one.
I'm still planning.
I have one that I did a few years ago for the staff. Here, I'm going to show you something else in a second. I have one that I've done a few years ago for the staff, which is I got everybody who was on the staff at the time Raspberry Pi zero Ws, and I formatted a card and put Raspberry Pi OS on it, and then I put like a greeting message on the home screen, so on the desktop, and I told them that in order to see my card to you, you have to launch the Raspberry Pi Zero and play the video. So I made each person like a 2 or 3 minute like video message. So I mean, it wasn't like very high tech. It was just they didn't have Raspberry Pi Zeros. I said, if you want to see my message in the card, you've got to use it. So, so I did, so I did that. It was a fairly inexpensive gift for people because all I had to do was buy the Pi Zero W and micro SD card. Granted,
Make it work for it, Avram.
Yeah, I made the work part because you also, with the Raspberry Pi Zero W, would probably want to have a mini HDMI to HDMI cable, which most people don't have lying around the house. So maybe that wasn't fair. Although they could always use VNC or something and then copy the video off, which I know some of them did. But that's something that you can do to encourage somebody, get them a Raspberry Pi Zero W and put something cool on it. At the time it was, I hope none of them are listening. They don't know how cheap I was. At the time, Micro Center, if you live near Micro Center, which I know there's only like 20 of them in the US, and they're mostly in like the East and maybe a little bit in the Midwest, is like the cheapest place to get Raspberry Pis. And at the time, Raspberry Pi Zero W there was $5. They have since raised the price. So now it's like $5 for a Zero without Wi-Fi, and then $10 for the W, and you can only buy one at a time. So I had to go back like 8 times. Over the course of a couple of weeks, but it was cool. Now I'm not going anywhere because of the COVID situation, but definitely I encourage that. One thing I wanted to show before we're out of time is last week we were talking about LED matrices, and my son and I were inspired to start working on our own LED matrix game, and we got to we have a game that runs on the Unicorn Hat, but we wanted to start with like a menu, and I figured I would show people how easy it is to kind of do something like this. So here's like the settings menu, and one thing that we programmed is that if you hit the keyboard, you can go kind of up and down on this, and it changes light, and then you can we got so far last night is to get the quit part to work. So if I hit enter, it'll quit. This is a 64 by 32 matrix. I got this one on Amazon for $35, but the cheapest way to get them is AliExpress has some for $13, and I've just ordered some from there, but I have to say I don't know. I can't vouch for the quality of them. On back here, I've got a Raspberry Pi Zero W, and it's using the Adafruit LED Matrix Bonnet, which I think is around $15, and it's connected to an external power supply that is 5 volts, 4 amps. Now, I just wanted to show really quick how simple this is to do with code. So over here, I have up on my screen the code, which I have on my Windows PC just to make it easier. And there is a library called Keyboard that you want to install. And of course, you want to install, this is on GitHub, the RGB Matrix and the RGB Matrix library, and the, I believe this is Pillow library for image drawing and the font. So the keyboard library is really important because if you want to make a keyboard key like the up arrow work, particularly when you're not running X Windows, this library is for that. So very simply, what I did here is I set a variable called current highlight to show which of the menu items is highlighted, and I start at 0. And then I have a menu that has loops to keep it going right now. I have this function draw menu, and what it does is it takes whatever key you've pressed, up, down, or enter, and or nothing when it starts, and it redraws the menu. If you hit up or down, it changes the current highlight number. If you go up, if you're going, up higher than 0, it takes you to the last item, which is item 2. And if you go down lower than item 2, it takes you back to 0. And if you hit enter, it fires another function. And then it goes through the array of menu items that I have to get you, which is here, to get you to sort of print the names of all the items. And if it's highlighted, it does it in the highlight color, which is white. And if it's not, it does it in the regular color, and it uses the draw text function from the draw library. And then you just set the image to appear at 0, 0 means the upper corner. So the key thing for the keyboard is that you use this method called add hotkey. You tell it what key it's looking for. You tell it to use Lambda to tell it you're calling a function, and then you feed the function, which I create a draw menu, the key up, down, or enter. Here's my array of menu items. Right now, I haven't done much with the enter menu. It just quits if you do the quit part. If you're using the matrix stuff, you want to set your options, and it's really important if you're using the Adafruit hat that you make this say Adafruit hat, not regular, and you set the number of rows and columns. And then this is really simple. You always set up the matrix, the size of your image, which usually you would probably want to be the same as your whole screen. Set it to draw. Here I've set a font, which is a font that I downloaded from Google Fonts because it looks 8-bit. I've set the RGB for my colors, and then I call draw menu the first time so that it draws it when you haven't hit a key. And now it's just kind of running an endless loop until you exit. So it's pretty simple. My point is it's pretty simple to at least get this up and running. And then, of course, the next step in this project is to actually put some of the cool games on it, to actually program some games for it in Python. We already have a platformer that we've programmed for the unicorn hat that we're going to take to the next level by putting it onto here. And, keep it going. But since we talked about LED matrices, I wanted to talk about how easy it is to kind of get started with drawing things on an LED matrix. Well, that's all. That's about all the time that we have. All the time that we have today. Someone says, quick tip: buy via multiple email addresses to buy a few Pi Zeros at a time. Okay. If we're but with Micro Center, you have to go in person. So that won't help with them, but maybe another vendor.
Do they let you just walk out and walk back in?
We didn't test that. We didn't test, and they will sell you more, but at a higher price. Like, the second one is like $15 or $20 or something. So, anyway, that's about all the time we have now. I really want to thank John Jones for joining us. A real pleasure to have you.
Thanks for having me. It's
we
awesome.
Look forward to seeing what's next with your rocket, and we'll see the rest of you next week.